Hi, in this video we are going to see about a Python IEEE project which is entitled as Machine Learning Based Stress Detection Using Multimodal Physiological Data, which is an enhancement of IEEE base paper title Machine and Deep Learning Models for Stress Detection Using Multimodal Physiological Data, which is an IEEE 2025 journal paper. Before seeing the execution of the project, let me brief about this project. In this modern world, every human being has the problem of having the large stress. The problem with the stress is like it will be affecting the mental health of the human being. So identifying this stress in the early stage will be helping and also helping to cure from that stress. So but identifying that stress should have some scientific approach. So in this base paper, the authors have utilized the machine learning and deep learning models for the stress detection. So in this base paper, the authors have used various wearable sensors for the prediction of the various parameters like 3-axis acceleration, ECG, blood volume pulse, body temperature, respiration, EMG, electrodermal activity, EDA kinds of things, and they have used VSAT data set, and they have used various machine learning algorithms like logistic regression, Gaussian Navy based classifier, CatBoost classifier, XGB classifier, decision tree classifier, extra tree classifier, and random forest classifier. And they have used deep learning models like deep neural network, convolutional neural network, and RNN. And finally they have achieved 93% the deep learning model of RNN, and they have achieved 99% for the machine learning models like random forest, extra trees, and XGB. So these details are being mentioned in the base paper. So kindly note that we are not going to do the same as mentioned in the base paper. So now let us see about what improvements that we have done from the existing system, that is from the base paper part. So now let us see about the proposed system. So here you can see the proposed title, machine learning based stress detection using multimodal physiological data, and this is the existing, that is IEEE base paper title and IEEE base paper abstract. Now let us see about our proposed abstract. So as mentioned, stress has become one of the significant health concern, and also it has various issues on physical, psychological, and behavioral disorders. So the traditional or existing stress assessment methods such as self-report surveys or clinical evaluation or wearable monitoring devices that is used in the base paper often suffer from limitations like high cost, limited accessibility, and lack of continuous monitoring kinds of things. So to overcome all these issues, we have presented a scientific approach that is using the machine learning based model for the stress level detection using multimodal physiological data from the Pillow dataset. So this is the dataset that we have used. So the dataset records contain 630 dataset records with 9 physiological attributes. So the attributes like snoring rate, respiration rate, body temperature, limb movement rate, body oxygen level, eye movement, hours of sleep, heart rate. So these kinds of things are used, and also we'll be detecting the stress and also the stress levels from low to high also. So we have implemented using the Python as the core programming language, and we have used HTML, CSS, and JavaScript for the front end, and for the web framework we have used Flask. So these are all the details that is mentioned regarding the project. So before moving to the next part, let us see about the data set part. So as mentioned, so the model contains the Pillow data set. So here you can see, I'll just scroll down till the end, and you can see it contains around 630 dataset records with the features that we have mentioned. So this is the dataset that we are going to use. So now coming back to the abstract part. So now let us see about the model that we are going to use. So here we are going to use two different models. One is the CatBoost Classifier, and second one is the stacking classifier. So using the CatBoost classifier, we have achieved 100% accuracy both on training and testing. Coming to the stacking classifier, we have achieved 100% on the training accuracy and we have achieved testing accuracy around 97.62%. So from the existing system, our proposed system has increased the accuracy, and other than that we have changed the data set and we have also increased the classification of the stress, and we also provide the stress detection and classification of the stress, and also we provide the recommendations based on the stress level that is detected, and we have increased the classes from the existing system. So these are the things that is made as a contribution from the existing one. So all these details have been mentioned in the abstract part of the project. So coming to the existing system, so we are going to consider the base paper as the existing one. So in the existing system, they have used machine and deep learning model for the stress detection. So they have used the VSAD dataset, that is variable stress and affect detection dataset. So that is collected from the wearable devices like wearable chest and wrist mounted devices. So these devices record multiple biosignals, including this ECG, electrodermal activity, EDA, blood volume pulse, body temperature kinds of things. So everything is being recorded from the wearable devices. So existing system process these signals and extracts the data from it, and then they have applied the various machine learning and deep learning models as mentioned. And here they have two phases. That is, one phase they have trained on the data from selected subject and tested on the remaining subject to evaluate the cross subject generalization. In phase 2, data from all subjects is combined and split into 80:20 ratio to evaluate the model performance when trained and tested on the same population set. So in both the phases, the existing system demonstrates how different model performs on the chest and the wrist data, identifying the optimal classifiers for various conditions kinds of things. So all these details are being mentioned in the existing system of the project. Coming to the disadvantages of the existing system. So the main disadvantages of the existing system are high dependence on multiple sensors, high computational cost for deep learning models, generalization challenges across different subjects, potential overfitting when training and testing on same subject, resource intensive data pre-processing, limited real-time applicability, dependence on control laboratory data. So each subheading explain detailedly about the disadvantage of the existing system. So now let us see about the proposed system. So to overcome all the issues that is mentioned in the existing system, we have proposed the machine learning based stress detection and also the classification system, which is using the SAYO-PILLO dataset, which is employing the two different machine learning models, especially the CatBoost classifier and the stacking classifier. So here we are going to take the physiological data from the data set, which is contain the snoring rate, respiration rate, body temperature, limb movement, blood oxygen level, eye movement, sleep duration and heart rate kinds of things. So first thing is like in the proposed framework we'll be having the data pre-processing where the raw physiological attributes are cleaned, normalized and formatted for the machine learning workflow. Following the pre-processing, the data set is divided into training and the testing subset to ensure the reliable model evaluation. So the CatBoost model is trained to capture the nonlinear relationships between the physiological indicators and the stress level, while the stacking classifier integrates output from multiple base learners to strengthen the prediction capability. So the proposed system is implemented using the Python for the backend processing, and for the web framework we have used Flask, and for the front-end part we have used HTML, CSS and the JavaScript. So the trained machine learning model is deployed within the Flask environment so that the user can able to enter the values and they can able to see the prediction results and also the recommendations for it. So the proposed system also incorporates a structured architecture consisting of data pre-processing, machine learning, model training, model serialization using Pickle, and real-time prediction to the web interface. And also we show the performance evaluation parameters and the graphs in it. So these are all the things that is mentioned in the proposed system of the project. Next, let us see about the advantages of the proposed system. The main advantages of our proposed system are reduced system complexity through fewer sensors, high prediction accuracy, efficient use of multimodal physiological features, lightweight architecture suitable for real-time deployment, user-friendly web interface, easy integration and deployment, supports file-level stress classification, cost-effective implementation. So these are all the main advantages of our proposed system. Each subheading explained detailedly about it. Next, let's just see about the system architecture. This is the overall system architecture where the inputs are your physiological data set has been given and pre-processing of feature selection is made, and that has been trained with the CatBoost classifier and the stacking classifier, and the prediction result will be low or medium low or medium high or high. And finally we show the performance analysis parameters on the graph part. And these are the system requirements. This is the minimum hardware requirements for the project. And in the software requirement, this project can be executed in Windows 10 or 11. The coding language uses Python 3.12.0. Web framework is Flask. Frontend contain HTML, CSS and JavaScript. And this is the IEEE base paper reference of it. So now let us see the execution of the project. So just go to the source code folder. Inside the source code folder, we have the stress app. Just go into that. Inside we have the app.py other files. So here in the address bar, let me type cmd and click enter. So the command prompt window open with the exact location of it. Now type python space app.py and click enter, and kindly wait for a few minutes. So now you can see the URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome. Paste it, click enter. So now you can see the project home screen or welcome screen with the project title machine learning based stress detection using multimodal physiological data, and you can see the static features of the home page of the project. And now let us go into the login. So just select this login menu. It will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and click the login button. So now you can see the login is success, and it navigates to the system where you need to upload the dataset. So just select the dataset. So just go to the project source code location. So inside the source code folder, we have the upload.csv. Just select this and then click upload and preview. So now the dataset has been uploaded, and you can preview the dataset. You can see the total records available, 630 columns, total values available, and you can see those things, the entries here with the 10 entries you can see, and you can see the complete dataset has been uploaded. And after that, just scroll down till the end of the page. You can see the train or test button. Just select this, and now you can see the training finished. So now let us go to the prediction part. So in the prediction page, you can see the various parameters. So you can just enter those parameters, and here you can see you can choose the model. We have given both the model stacking classifier and CatBoost, whichever you wanted you can select. I'll show you with the both the cases with the all other classes that is available. So first let us enter the snoring rate for the first. Let me enter the snoring rate as 96.25. So these values which I'm entering is already available in the data set and in the train and test folder. You can just check it out. So let me enter the respirator as 26.25 and body temperature as 85.32, heart rate as 75.64, blood oxygen as 82.38, and limb movement as 17.12, eye movement as 100.32, and let me select the first case model as stacking classifier model, and let me click the analyze stress level. So now it will be navigated to the result page where you can see the first predicted result is high, that is stress level 4 of 4, and you can see the parameters whatever that I have entered, and you can see the personalized recommendation that is provided according to the stress level that is going to be predicted. So this personalized recommendation for this case is: critical stress level detected, seek help immediately, schedule an appointment with a doctor or sleep specialist, avoid vigorous exercise close to bedtime, create a dark, quiet, cool sleeping environment, consider professional stress management counseling, explore sleep therapy or medication under supervision. So you can also download the predicted results. You can just click this download PDF report and just let us save it in the desktop. I'll just save it as one.pdf. So this is the first exported result. So you can see the values that we have entered, and you can see the model that we have used, and you can see the personalized recommendation. You can see the result is high. So now to predict another case, let us select this new analysis. So now let me enter the second case, snoring rate as 93.8, sleeping hours as 1.84, respiration rate as 25.68, body temperature as 91.84, heart rate is 74.2, blood oxygen as 89.84, limb movement as 16.6, eye movement as 99.6. Now this time I'll just select the CatBoost classifier and let us check the predicted result for this by clicking analyze. So now you can see the next case that I have given shows the medium high, that is 3 of 4. So you can see the parameters that what I entered, and you can see the model that I have selected, and here you can see the personalized recommendation. So it varies according to the stress level that is going to be predicted. So here you can see the personalized recommendations are: your stress levels are concerning, take action now, consult a healthcare professional for guidance, prioritize 8 to 9 hours of sleep nightly, avoid stimulants, caffeine, alcohol before bed, try progressive muscular relaxation techniques, consider cognitive behavioral therapy for insomnia. So these are the personal recommendation that is provided, and you can also download the predicted result. I'll just save it as 2.pdf. So you can see the exported result. Now let us go for the new analysis, and let me give another case here by entering the snoring rate as 78.56, sleeping hours as 4.78, respiration as 21.85, body temperature 93.85, heart rate as 64.64, blood oxygen 91.85, and limb movement as 11.85, eye movement as 94.28. And let me select the stacking classifier and let us see the predicted result for this. And now for this third case, you can see it is predicted as the medium, which is stress level 2 of 4. So here you can see the parameters that I have provided. These are all the input parameters I have given, and you can see the personalized recommendations here are moderate stress detected. So take proactive measures, establish a consistent sleep schedule, proactive deep breathing exercise 4, 7, 8 technique, consider yoga or meditation classes, reduce screen time 1 hour before sleep. So these are all the personalized recommendation that is provided for this case and class. Let me save it as 3.pdf. So now you can see the exported result for this case. So now let us go for the new analysis. So I'll just give the snoring rate for this case as 67, 20, 96, 60, 95, 10, 85, And now let us select the CatBoost and let me analyze the stress level. And now you can see this shows the medium low, that is 1 of 4. So these are the parameters that I have provided, and you can see the personalized recommendation, or your stress is slightly elevated but manageable. Aim for 7 to 8 hours of quality sleep each night. Try relaxation technique before bedtime. Limit caffeine intake after 2 p.m. So these are all the things that is being provided for the personalized recommendation for this case of medium low. And you can just download this predicted result. For this case, I'll save it as 4.pdf for the future reference. It has been saved. And now let me go to the final case, new analysis. I'll just quickly give the snoring rate 48.44, sleeping hours 8.37, respiration as 17.37, 90 body temperature as 98.06, heart rate as 53.44, blood oxygen 96.37, and limb movement 6.75, eye movement 73.76. And now I'll just select the CatBoost and let us analyze the stress level. So now you can see it is low or normal, that is 0 or 4. So you can see the parameters that I have entered, and you can see the personalized recommendation for this class is like excellent. Your stress levels are optimal. Continue maintaining your current sleep routine. Keep your regular exercise and healthy eating habits. Practice mindfulness for 15 to 10 minutes daily. So you can just download this report for future reference. I'll just save it as 5.pdf. So I have shown you 5 different cases. So all these things have been exported here, which shows the various stress levels from 0, 1, 2, 3, 4. So, and also the personalized recommendation for this. So you can check with all other cases that is available in the data set of train or test, and you can show various results. So now let us move to the next one, that is the performance analysis. So just in the menu part you can see the performance. Just select this, so you can see the performance analysis parameters for this project. So we have used 2 different models, that is one is CatBoost and stacking. So CatBoost has achieved 100% accuracy, and stacking classifier has achieved 97.6% accuracy. And you can see the CatBoost classifier confusion matrix here. So this is the to unpredicted label for the CatBoost, and you can see the precision, recall, F1 and support score for the classes of low, medium, medium high and high. And similarly, coming to the stacking classifier, you can see the confusion matrix of the stacking classifier, and also the precision value, recall value, F1 score and support score for the classes of low, medium, high and the normal cases. So this performance analysis parameters shows the details of the model accuracy, confusion matrix, precision, recall, F1 and the support score for both the models of the CatBoost and the stacking classifier. And finally, let us go to the chart part. So this is the static visualization chart. So here you can see the charts showing the model accuracy comparison, which shows the CatBoost with the test accuracy 100% and train accuracy with 100%. Coming to the stacking classifier, train accuracy with 100% and test accuracy with 97%. Coming to the next chart, that is the model accuracy trend, which shows the both the model stacking classifier 100% and stacking classifier 97%. And here you can see the data set distribution, which contains the low with 20%, medium low with 20%, medium with 20%, medium high with 20%, and high with the 20%. So this is the stress level distribution that is available in the data set that we have used. So these are all the things that is available in the chart part. So now before completion, let us see the frequently asked question for this project. The first question is, what is the main purpose of this project? So the main purpose of this project is being developed because to predict the stress and also to classify the stress level, so that they can able to identify which level of stress they are having, and accordingly the recommendations are provided so that they can take the treatment early and avoid unwanted things. Next question, which dataset is used in this project? So this project uses SAYO Pillow dataset, which contains 630 dataset records. Next question, what machine learning models are used for the stress detection? So we have used two different models. One is CatBoost Classifier, other one is a stacking classifier. Next question, what are the accuracy results that we achieved for this model? So ClassBoost achieved training accuracy 100%, testing accuracy 100%, stacking classifier achieved training accuracy 100%, testing accuracy 97.62%. Next question, how many stress levels does the system predict? So here we have predict 5 different level of stress levels. 0 means low, 1 means medium low, 2 means medium, 3 means medium high, 4 means high. Next question, what physiological features are used as the input? So we have used SR, that is snoring rate, RR as respiration rate, T is a body temperature, LM is limb movement rate, BO is blood oxygen level, RM is eye movement, SR is sleep hours, HR is heart rate, SL is a stress level. That is the output category. That is, these all the things that is available in the dataset part. Next, which technologies are used to develop the system? So we have used Python as a core programming language, and we have used HTML and JavaScript for the front end, and we have used Flask as a web framework. How does the user interact with the system? So user will be entering the physiological data in the web form. The system processes these inputs and it will be sending to the machine learning models, and it will be displaying the printed result, and also it shows the personalized recommendation according to the printed result. Next question, is the system capable of real-time stress detection? So currently the system predicts based on the manual input only. Real-time detection of using the sensors can be possible, that can be integrated in the future enhancement, but not in the current one. Next question, how are the machine learning models integrated into the web application? So the trained model is being saved as the pickle file. The Flask load the model at the runtime and process the user input and send them back to the model and renders the printed output to the user interface. Next question, what makes CatBoost suitable for this project? So CatBoost Classifier automatically handles the feature interactions, works well with the smaller data set, and it provides high accuracy without extensive pre-processing or parameter tuning. So this project is achieved per perfect prediction performance. Next question, what are the expected outcomes of the outputs of the system? So the output of this stress level prediction is 0 to 1 along with the corresponding stress category such as low, medium or high kinds of thing are the expected outcome of the system. Next question, what makes the system different from the traditional stress detection method? So the traditional methods rely on the personal surveys or clinical assessment or wearable devices, which may be subject to costly, or it is not a continuous process kinds of things. So this system uses objective psychological signals and machine learning algorithms to provide automated and the data driven stress prediction. So from the traditional stress detection method, so we have been achieved with the scientific approach and also accurate model, and increase the percentage of the accuracy, and also increase the classification of the stress classes, and also we have provided with the option of the stress level and their personalized recommendation according to the printed class of it. So these are the frequently asked question for this project. This is all about the machine learning based stress detection using multimodal physiological data using Python, and thank you for watching.